Happy Union Day, students. Today we are going to discuss the objective model question bank. Objective model questions for your objective exam 2. If you look at the unit 3 model questions, the property of becoming electrically polarized when mechanical stress is applied is known as, which is nothing but the piezoelectricity. You are having the 4 options, but the correct one is piezoelectricity. The polarization vector is option A P times mu, option B N into P times mu, option B is the correct answer. The dielectric material is, among the following, copper is conductor, aluminum is also semiconductor, silicon is, so D, mica is the correct answer. And then the polarization vector P is defined as dipole moment per unit area, dipole moment per unit volume. So option B is the right answer. The ratio of dipole moment to dielectric field strength is known as option D, polarizability. And then coming to the sixth one, dielectrics are used to increase the charge on the capacitor, to decrease the charge on the capacitor, to stabilize the charge on the capacitor. All of the above. Dielectrics are used to all of the above. And then the dipolar, the seventh one, the orientation polarizability depends upon the temperature as inversely proportional to depends upon the temperature. And then dipolar polarizability exhibits remarkable variations near the following frequencies. It is microwave frequency. Option A is the right answer. Ionic polarizability proves remarkable variation near the following frequencies. Option B, infrared. The expression for the electronic polarizability directly, that is option C, 4 pi epsilon naught r cube. The electrical susceptibility Xi equal to P by E. Option A is the right answer. The expression for the electrical displacement D equal to epsilon naught E plus P. Option D is the right answer. The dielectric material can be polarized by applying an electric field. Option A is the right answer. In hysteresis, the polarization lags behind the electric field. Option A is the right answer. If a material is ferromagnetic, what shall be the value of Xi? If it is ferromagnetic, it is large and positive. Option C is the right answer. Which of the following diamagnetic material among the given, option D is the right answer. That is nitrogen is the correct one. And then material in which the magnetization persists even after the field has removed are called, we call it as hard ferromagnetic materials. So option D is the right answer. And then at high temperature, a ferromagnetic becomes paramagnetic. Option B is the right answer. And then which material is shown in the figure? It is a paramagnetic material. Option B is the right answer. And then the value of B at H equal to 0 in a hysteresis curve is called, it is called retentivity. Option A is the right answer. When a ferromagnetic rod is placed in a solenoid with current, what happens to the rod? It is permanently magnetized. Option C is the right answer. And then what does the following curve shows? It is the hysteresis loop. BH curve. It is nothing but hysteresis loop. Option B is the right answer. Then coming to the magnetic material in which the permanent atomic magnetic dipoles have parallel orientation is termed as which one of the following? Option C, ferromagnetic material. And then example for diamagnetic material. Copper is also bismuth, H2. All are the above is the correct answer. Option D. All are diamagnetic only. The strongest diamagnetic material. Option C. And then coming to the units of relative permeability. No units. Weber, Tesla, ampere per meter. Relative permeability is nothing but mu r. Option D is the and then spontaneous magnetization is present in option C, ferromagnetics. Exactly correct. The magnetization per unit magnetic field intensity is called option C, magnetic susceptibility is the correct answer. Nickel is diamagnetic, ferromagnetic. Option C is the right answer. Now coming to the model objective questions in unit 4. The de Broglie wavelength of a particle of mass m and charge E is given by lambda is equal to option B is the correct answer, h by root over 2 MeV. The velocity of matter wave varies with the velocity of the particle. Option B is the right answer. The concept of matter wave was suggested by de Broglie. Option B is the right answer. And then de Broglie hypothesis states that dual nature of light, dual nature of no, it is dual nature of matter. Option C is the right answer. Dual nature of matter. And then coming to the next one. The wavelength associated with the de Broglie is known as option C, matter wave wavelength. Exactly correct. Schrodinger time independent wave equation is classical differential wave equation, electromagnetic wave equation. It is a differential wave equation. Option A is the right answer. It is the differential wave equation of matter wave. Option C is the right answer. Coming to if the momentum of a particle is increased 4 times, then the de Broglie wavelength will becomes, it is A 2 times, B 4 times, 1/4 times. Option D is the correct answer. De Broglie wavelength of an electron which has accelerated from rest through the potential difference 100 volts is given by option B is the correct answer, 1.227 angstroms. According to wave mechanics, a material particle is associated with a wave packet. Yes, exactly. Option B is the right answer. The wavelength of matter waves is independent of charge. Yes. Option C is the correct answer. Assuming the velocity to be same, which particle is having longest wavelength? Electron, proton, neutron, alpha particle. neutron has the longest wavelength because its mass is less. The rest mass of proton is infinity. Option D is the correct answer. A photon and an electron have the same wavelength, then electron has greater momentum. Option B is the correct answer. And then if an electron is subjected to 54 volts, then its wavelength is option B 0.167 nanometer. Dual nature of matter was predicted by option B de Broglie, Louis de Broglie. Uncertainty principle states that the error in measurement is due to dual nature of particles, due to small size of particles. Yes, option A is the right answer. Which of the following act as a both particle and wave? Photon, electron, neutron, all of these. Yes, all of these will act as a both. So option D is the right answer. A proton of energy 2.05 mega electron volt has a de Broglie wavelength of option C. This model problem we already solved in the classroom. Just you have to solve it. The velocity of X-rays in the vacuum is less than the velocity of light, equal to velocity of light, greater than velocity of light. None of these. Option D is the correct answer. X-rays were discovered by mostly, yes, option A is the right answer. The walls of a particle, sorry, option D, Röntgen is the correct answer. We can change the question, then option C is correct answer. X-ray diffraction was discovered by X-ray diffraction was discovered by Bragg. Option C is the right answer now. The walls of a particle in a box are supposed to be small but infinitely hard and infinitely large. Option D is the correct answer. The wave function of the particle lies in which region? The wave function of the particle lies between 0 and L. It is length of the particle. Option C is the right answer. For a particle inside the box, the potential is maximum at x equal to A. Or L, that is control. Rood and Lawrence developed classical free electron theory. Option A is the right answer. The state function psi of x, physical dimension of quantum free electron theory, was proposed by option A, Sommerfeld. Correct answer. Boundary conditions are used to find the wave function. Option C is the right answer. The wavelength of a photon of lambda 1.2 angstrom, the energy of photon electron volts. Then it is given by in the electron volts. It is, you can just practice it. It will. Option C. The wavelength of a photon with momentum 10 power minus 23 kg meter per second is option B. And then with the increase of the temperature, the resistance of the metal also increases. Option A is the correct answer. And then model questions on unit 5. The electrical conductivity of semiconductor lies in between the conductor and the insulator. Option B is the right answer. And then in the Hall coefficient, if the Hall coefficient is positive, then the semiconductor is P-type. Option B is the right answer. In pure semiconductors, the electric current is due to the option A, electrons and holes. Diffusion coefficients and mobility relation is given by Einstein. Option C is the right answer. When a small amount of pentavalent impurity is added to a pure semiconductor, then the resulting semiconductor is called N-type semiconductor. Option B is the right answer. Electrical conductivity of a semiconductor at absolute zero temperature is 0. Option C is the right answer. The Einstein relation between the diffusion coefficient constant and the mobility of an electron is dN by mu n is equal to k suffix b into t by. Option A is the right answer. In an intrinsic semiconductor, the Fermi level lies at the center of the energy forbidden gap. Exactly correct. Most of the commonly used semiconductor material is mixture of silicon and germanium. Option C. At room temperature, a semiconductor material is a conductor. At room temperature, semiconductor material is a conductor. Option B is the right answer. For the silicon, the energy gap at 300 Kelvin is silicon energy gap is 1.1 electron volt. Option C is the right answer. The forbidden gap for a germanium is option B, 0.72 electron volts. The process of adding impurities to pure semiconductor is called doping. Option B is the right answer. The pentavalent impurities like antimony, arsenic, bismuth, and phosphorus added to intrinsic semiconductor are called option D, donor or N-type impurities. Impurities like boron, aluminum, gallium, indium are added to intrinsic semiconductor to form P-type doped semiconductor. Option B is the correct answer. In N-type semiconductor, the position of the Fermi level is option C, near to the higher than the energy gap. Yes. Option C is the right answer. The mobility of an electron in a material is expressed in terms of meter square per volt second. Option B is the correct answer. As the temperature increases, the resistivity of a semiconductor remains the same. Temperature increases, resistivity decreases. It is a negative temperature. Remains the same. It is a P-type. The temperature increases, resistance decreases, hence the current increases. So option D is the correct answer. The energy gap in a semiconductor B does not change with temperature. Yes, energy gap does not change with temperature. Exactly correct. A semiconductor is formed by covalent bonds. Exactly correct. Option A. Semiconductor has dash temperature coefficient of resistance. Negative temperature coefficient of resistance. So option C is the right answer. A semiconductor has generally dash valence electrons. Semiconductor has 4 valence electrons, tetra. Hence it is option D. The strength of the semiconductor crystal comes from electron pair bonds. Option C is the right answer. As the doping to pure semiconductor increases the bulk resistance of the semiconductor. Option A. Remains same, increases, decreases. Doping to pure semiconductor increases the bulk resistance of the semiconductor. No. So it remains same. Doping to pure semiconductor increases the bulk resistance. No, it decreases. Option C. The random motion of the electrons and holes due to thermal agitation is A. Diffusion. Exactly. In Hall coefficient negative, then the semiconductor is a n-type semiconductor. Option A is the correct answer. If the Hall coefficient is positive, then the semiconductor is a p-type semiconductor. Option B is the correct answer. The electron vacancies in the valency band of a semiconductor will exist as holes. Yes, which behaves as a positive charged particles. The expression for the conductivity in a intrinsic semiconductor is option C, sigma equal to n times I into mu E plus mu H. For n-type semiconductor, the Hall coefficient RH is equal to minus 1 by Ne. Option D is the right answer. So these are all the model questions. All the best. Good luck.